Okay, guys, welcome. Today we're going to talk about some additional trigonometric functions. So far we've talked about sine and cosine being our two sort of main trig functions so far. We're going to introduce a couple more of them. We're going to introduce the remaining trig functions, which are, first of all, we'll talk about what the tangent of an angle is, and we'll talk about how we can find the tangent of some common angles. We'll also talk about how to find the equation of a line that makes a given angle with the positive horizontal axis. And then we'll also talk about the reciprocal trig functions, which are secant, cosecant, and cotangent. All right. So the next trig function that we're going to introduce is the tangent of an angle. Now, the tangent of an angle is given by the ratio of the sine and cosine functions. And of course, this is assuming that cosine is not equal to 0, of course, which can happen, right? And sort of an equivalent way to think of our tangent of an angle is, since you have that sine is like your y value and cosine is your x value, you can think of the tangent of your angle as sort of being your y value over your x value. Okay, so another thing that's sort of interesting is that if you think of your tangent as being y over x, since your origin on all of these points is one endpoint of your radius, then you can think of y minus 0 over x minus 0, of course, being the slope of a particular angle, right? So it's the slope for any given angle. Okay, so this is sort of how we can define tangent in another way using our sine and cosine. So sort of by this figure here. Okay, so with that being said, let's go ahead and let's do an example here. So first of all, we want to evaluate tangent of pi over 4. Well, the first thing that we need to do is we need to, and again, if you're not comfortable with pi over 4, which of course is in radians, let's convert it to degrees. So I need to multiply it by 180 over pi, and my pi's would cancel. And if I divide 180 by 4, you'll find that that is a 45. So this corresponds to a 45-degree angle on the unit circle. So let's draw this out. Okay, so if we draw our 45-degree angle, we are looking at something like this. All right, which is also pi over 4. Now, in order to get the tangent of this angle, we need to figure out the x value and the y value so that we can do y over x. Well, if this is a 45-degree angle, then what we really have here is a 45, 45, 90 triangle sitting here. So of course, what do we know? If we have a radius of 1, we know that each of these sides are square root of 2 over 2. All right, so this is like my y value, and this is like my x value, or again, you could think of this as your cosine, and this is your, I should do the angle here, cosine of theta, and this is like sine of theta. Well, again, tangent of pi over 4 is sine of pi over 4 over cosine of pi over 4. But sine, the y value, is square root of 2 over 2. And so is the cosine, also square root of 2 over 2. Now you could, do your keep, change, flip, and multiply these two fractions here, or you could see that you have something divided by itself. So of course, this is just equal to 1. So the tangent of pi over 4 is equal to 1. All right, so that's one example of how to compute the tangent. All right, and of course you could do a similar thing for these additional angles here, right? So a good exercise might be to verify that a lot of these would, of course, give you those associated values for tangent. All right, now one that I do want to do sort of off to the side here is just this undefined value of tangent. So we're claiming that if I do tangent of 90 degrees or pi over 2 radians, that's going to give me something that's undefined. And of course it will, because this is sine of 90 over cosine of 90. But if you look at the unit circle, and if you look at 90 degrees, of course, what's this coordinate here? This is the coordinate 0, 1. So the sine of 90 is the y value, which is 1, and the cosine is the x value, which is 0. So of course, once you divide by 0, that's when you get the undefined. All right, so you're actually going to get two angles that would give you undefined. You'll get the 90 degrees or the pi over 2, and then you're also going to get down here, because here the x value is 0 as well. And then of course that will be at 270 degrees or at 3 pi over 2. Right, so that will also occur here. Okay, so next let's look at how we can find an equation by using the tangent. Okay, so we want to find the slope of this line that contains this point 3, 1 and makes an angle of 28 degrees with this positive x-axis. So this angle here is 28 degrees. Okay, now here's what we sort of have here. If I draw this triangle out to the side, well, I have a 28-degree angle here. This is a right angle. All right, we don't really know what this angle is, but if you think about that you have 180 degrees in a triangle, you can show that this is 62 degrees. Now, the problem is that this isn't one of our more known triangles, but we already have these lengths here, right? We have that this length is from 1 to 3, so that's a length of 2, and that this length here is from 0 to 1 in terms of y, so this is 1, right? Well, we know that the tangent of this angle of this 28 degrees is y over x, which is 1 over 2. And since that's my tangent of this, that's also the slope of this line. Right? So that's one way that you can sort of use the tangent here. Right? Now, of course, if you were to do this using the slope formula, you would get the same thing, right? Because this is the point 3, 1. This is the point 1, 0. And if you do 1 minus 0 over 3 minus 1, you also get 1/2 that way as well. Right? So you can use the tangent to sort of get the slope of that line as well. All right. Now we have the slope is equal to 1/2, and that we pass through 3, 1. So if we want to make an equation for this line, we can use point slope form, which of course is y minus y1 equals m times x minus x1. And so this will give us y minus 1 is equal to m, which is 1/2 times x minus 3. So we get y minus 1 is equal to 1/2 x minus 3 over 2. And then once we add 1 to both sides, we'll get that y is equal to 1/2 x, and then I guess this would be a minus 1/2. All right, so that's how you can get the equation of that line by using the tangent, right? The tangent just helps you get the slope. Okay. Now, the next observation that we're going to make here about tangent is what the signs are in each quadrant, right? And we can use this using the fact that we have sine and cosine. Now in this quadrant, both x and y are positive, so y over x, which is tangent, is positive over positive, which of course overall is positive. So that tells you that the tangent would be positive here. Okay, now in quadrant 2, your x value is negative, but your y value is positive. So y over x would be a positive over a negative, which overall is negative. So that's where you're seeing that tangent is negative here. Okay, and this, of course, the same will happen in this quadrant because here it's just now reversed. You have that x is positive and y is negative. So y over x is a negative over a positive, which overall is negative. Now be careful because in this quadrant, both sine and cosine are negative, but a negative over a negative becomes positive. So that's where you're getting that tangent is also positive here. All right, so that's one sort of important observation to note here. Okay, so let's take a look at an example. So we want to find the radius of the unit circle corresponding to an angle of theta such that tangent of theta is equal to 1/2. So we essentially need to find what angle gives me a tangent of 1/2, right? Well, let's use what we know. We know that tangent is sine over cosine, right? So we can say that sine over cosine is 1/2. Now, if we cross multiply, we could say that cosine is equal to a 2 sine of theta, right? So now we can use this relationship to help us figure out what the radius is going to be, right? So we want to know where is the y value if I multiply the y value by 2, does that give me the x value? Well, we can use x squared plus y squared is equal to 1, or sine squared plus cosine squared, to help us get this, and just use this fact here, right? So if x is equal to 2y, I can replace x with 2y and square that. So this will give me a 4y squared plus y squared is equal to 1. So I'm going to get that y squared is equal to 1/5. So that gives me that y is equal to plus or minus 1 over square root of 5, which we could say is plus or minus square root of 5 over 5. Okay. Now again, we know that tangent of theta is not only 1/2, but it's a positive 1/2. So this tells us that we're in quadrant 1 or 3. All right. And we know that if y, for example, is positive square root of 5 over 5, then x better also be positive so that we can get our tangent to be positive. So then this means that, remember, x is 2 times y, so we're going to get a 2 square root of 5 over 5. And of course, the other option is that you have y is equal to minus square root of 5 over 5, which would then make x minus 2 square root of 5 over 5. Okay, so finally, we can plot these points. And we can find out where the radius is. Now, of course, one option is you could get decimal approximations for each of these points here, right? But what we're going to do is we're going to use the fact that if our tangent is 1/2, that's like saying that the slope is 1/2. Right? So how would you normally draw this? Well, if you have a slope of 1/2, that means that you would go up 1 and over 2 and draw a line. So you'd have something like this right here. All right. And of course, this is not drawn to scale, but as long as the slope is 1/2, then this is the radius that corresponds to tangent of 1/2. All right. And what you could, of course, also do is you could say that this is the point square root of 5 over 5 2 square root of 5 over 5. Now the negative version is just coming down this way. All right, but again, since it's negative over negative, this becomes a positive tangent value. And this would just be the point negative square root of 5 over 5, negative 2 square root of 5 over 5. All right, so you can sort of see that that's one way that we can find that angle, right? Okay. Now, if you have any one of these three angles, you can use these three equations to find the other two, sort of like we just did in the last example. In the last example, we were only given tangent, but that allowed us to find sine and cosine. And specifically in the last example, I guess we used both of these, right? So as long as we know the sign about the rest of the angles, or we have something to deal with what quadrant we're located in, we can find precisely what angle we must be talking about. Okay. So for example, let's take a look at something like this. Okay. Now we're given that our angle is in quadrant 3. All right. And we're given that the tangent of this angle is 4. So tangent of theta is equal to 4. We want to find sine and cosine of theta. Well, one thing that we can already say is because of the fact that we're in quadrant 3, we know that both of these have to be negative, right? So we know that sine and cosine both have to be negative, all right? Now we know that if tangent is equal to 4, then sine over cosine is equal to 4, because tangent is sine over cosine. And then we can say that sine of theta multiply the cosine over is 4 cosine theta. Okay, so now similarly to before, we can say that this is y is equal to 4x, or let me actually use this way, since this is what we just mentioned. You could use the y and x relation, but I want to use this one as well. We know that sine squared plus cosine squared is equal to 1. And of course, we can use this relationship to solve this. So I'm going to plug in a 4 cosine of theta for my sine and solve for cosine here. So this will give me a 16 cosine squared plus cosine squared is equal to 1. So I'm going to get that cosine squared, or if I add these two, I'll get 17. So I'm going to divide both sides by 17. And then when I square root both sides and rationalize, I'm going to get that cosine is equal to square root of 17 over 17. Right? Now, again, we said that cosine was negative, so I better put a negative there. Okay? So we have that our cosine is negative square root of 17 over 17. But now we can use this relationship again. We know that sine of theta is take your cosine of theta and multiply it by 4. So sine of theta is 4 times negative square root of 17 over 17. So my sine is negative 4 square root of 17 over 17. Right? So given only tangent, we were able to find both cosine and sine here. Okay. Now, a couple of things about the domain and range. We've already previously mentioned that sine and cosine both have a domain of every real number, right? We can plug in any real number. And we know that what we get has to be between -1 and +1, right? Now for tangent, it works out a little bit differently, because tangent, again, is sine over cosine. So in tangent, you potentially have a problem when this is 0. Problem when this is 0. And we know that cosine is 0 at pi over 2, and also at 3 pi over 2. But we also know that we'll repeat these when we add any multiple of 2 pi as well. Right? And so we get that the domain of tangent would have to be all real numbers that are not one of these odd multiples of pi over 2, right? Now the range for tangent is going to be everything, right? And the reason why is because as cosine gets extremely small, you're taking a number that's between -1 and 1 and you're dividing it by a really small number, you're going to make overall your number really large. So you can essentially make this as large as you want. Right? And that's where you're going to get this sort of funky looking graph here, where at these multiples of pi over 2, you're going to get an asymptote because that would cause division by 0. And close to that asymptote, you're either going to go towards infinity or negative infinity, right? So the graph of tangent is very different from the graph of sine and cosine, because of sine and cosine, you sort of get that, that sort of wavy activity, whereas in this one, you get sort of this weird spiking thing going on. Okay. Now we can talk about some other trig functions, right? So we can say that the secant of an angle, right, which is denoted by SEC, is 1 over the cosine. So these are examples of reciprocal trig functions, right? So secant is 1 over cosine. And cosecant, which we are usually denote by CSC, is the reciprocal, or 1 over sine, right? So one way that I've sort of always remembered this is that cosine is 1 over secant and sine is 1 over cosecant. And sort of in each of these relationships, you only have one co per relationship, right? So you know that cosine and cosecant don't go together because that would be two trig functions that start with the two letters co, right? So cosine is the reciprocal of secant, sine is the reciprocal of cosecant. All right, and we don't want tangent to be left out. And cotangent is also the reciprocal of tangent, or one way you can think of that is that it's just tangent flipped, right? So of course we still have the relationship that tangent is 1 over cotangent, but a lot of times it's easier to find cotangent as cosine over sine, right? So these are 3 more trig functions that are reciprocal sort of trig functions. All right, and this is of course the thing that we just said. Okay, so let's talk about how we can evaluate some of these reciprocal trig functions. So if I want to find secant of 60 degrees, that means that I need to find 1 over cosine of 60 degrees. So let's find cosine of 60 degrees. So if I draw 60 degrees, I know that I have an angle that's somewhere about here. And then I have a 30, 60, 90 triangle here. Right, so of course across from the 30 I have a 1/2. Across from 60 I have a square root of 3 over 2. And my hypotenuse is always 1. Now the cosine, again, is my x value. So the cosine of 60 is 1/2. But I don't want cosine, I want secant. So this is 1 over 1/2. And if you take 1 and you divide it by 1/2, that's just 2. So the secant of 60 degrees is 2. Okay, let's look at, so that was part A. In part B, let's do the cosecant of pi over 4. Now, if I want cosecant of pi over 4, that is, that is 1 over sine of pi over 4. So we need to find sine of pi over 4. Well, you can check that if you're, again, still not comfortable with radians, that sine of pi over 4 is just 45 degrees. And if you were to draw a 45-degree angle here, you're going to get a 45, 45, 90 triangle. And of course, you have square root of 2 over 2, square root of 2 over 2. So your sine of 45 is a square root of 2 over 2. But again, we want cosecant, which is 1 over sine of 45 degrees. So this is 1 over square root of 2 over 2, which if you change this to multiplication and multiply by your reciprocal, you'll get a 2 over a square root of 2. And then once you rationalize, you will get a 2 square root of 2 over 2. So your 2's cancel and you just are left with square root of 2. And this would be your cosecant of pi over 4. All right, and finally, part C, we're doing cotangent of pi over 3. All right, and I actually think I can reuse this triangle here, right? Because if you look at pi over 3, what is pi over 3? Well, in degrees, that's 60 degrees, right? So I can reuse this. Now, the cotangent is 1 over the tangent. Right? So tangent of pi over 3, again, is sine over cosine. And the sine of pi over 3, or sine of 60 degrees, is square root of 3 over 2. And the cosine, we just said a second ago, is 1/2. Now, if I multiply this, if I keep change flip here, I'm going to do square root of 3 over 2 times 2 over 1. My 2's will cancel, and I'll be left with square root of 3. So it looks like if I want cotangent, I want 1 over square root of 3. And of course, once I rationalize, I'll get that this is equal to square root of 3 over 3. And that's my cotangent. Okay, so that's how we can evaluate some of these other trig functions, right? So we just use their relationships and we basically find everything in terms of sine and cosine. Okay, so that concludes this video on the additional trigonometric functions. I hope you enjoyed, and I will see you next time.